Let's talk about constitutional isomers. So constitutional isomers, they have the same molecular formula, but different connectivity of their atoms. So if you have two, three, or more constitutional isomers, they almost have the same molecular formula, but how the atoms are connected must be different. Generally, your questions for constitutional isomers, you'll be given couple structures, two or more, and they will ask, are these constitutional isomers or not? Also, you can be given a molecular formula and asked to draw as many constitutional isomers as possible. If you are given the latter, honestly, to draw as many constitutional isomers as possible, that that's just you playing around with the different structures and putting the bonds in different places. The key after you play around with that is if you name the structures, if they have the same name, they're not constitutional isomers. They're just different representation of the same molecule. So let's look at how you name your constitutional isomers. So the first thing is you must determine if the compounds that you're given have the same molecular formula. So let's do that first. One, two, three, four. All I'm doing is counting the total number of atoms I have here. This is a line angle. Your hydrogens are not shown. So I have four carbons and I have 10 hydrogens. Now, if you are not sure how I got these 10 hydrogens, please revisit line angle structures. There are three hydrogens here, two here, and three here. So 3 and 3 is 6, and 2 8, and 2 10. Let us look at the other structure. We have one, two, three, four carbons. So my molecular formula is C4H10. Remember, molecular formula is all the individual atoms that is within the molecule. Now let's talk about the connectivity of these atoms. So if we look at our first structure here, I have one, two, three, four carbons in a straight chain. Let's highlight those. I have four carbons connected here. One, two, three, four, right? If we move over to the second structure, I have three carbons in a straight chain, and then on this carbon, I have a CH3 group. So it's obvious here that the molecular formula is the same, but the connectivity of the atoms is different because here I have four carbons in a long chain. Over here, I only have three carbons in my longest chain, and then on this carbon a CH3, right? Let's talk about this another way if we prefer. So let's see, we have one, two, three, four carbons in my long chain over here. Here I have one, two, three. The connectivity is obviously different because here I have four carbons in my long chain. There's nothing on carbon 2 here. Here I have three carbons in my long chain. Carbon number 2 has a CH3 on it, right? So these two are clearly constitutional isomers because the molecular formula is the same, but the connectivity of the atoms is different. We can, like I told you before, if you name these, you'll get different names, right? So for example, this is butane. If you don't know how I got butane, please see naming alkanes. And this is 2-methyl propane. Three carbons in your longest chain, and on carbon 2, I have a methyl group. So that's 2-methyl propane. Let us look at another example so I can show you something. So let's say, all right, let's talk about this example. So let's say you got this and you look at it and you're like, oh yeah, of course, these are these are constitutional isomers because just looking at them you think, of course, their connectivity look different. Please don't do that. This is what you do. right? Whenever you're given two structures to determine constitutional isomers, first thing, determine the molecular formula. Then find your longest chain of carbons and look. Once you find the longest chain, pay attention to the connectivity of the atoms. So let's do that in this example. And I specifically use this example because honestly, just looking with your naked eye, you probably got excited and say, yeah, they're constitutional isomers. Let's go through and look at how to handle constitutional isomers when you're given them. I know in the first example, this is exactly what I did, but these look so different. I wanted to highlight this. So, constitutional isomers, let's determine if these two are. First thing, let's determine if the molecular formulas are the same. 1, 2, 3, 4, 5, 6. I have 6 carbons. Um, this molecule is C6H14. If you don't know how I got the 14 hydrogens, please review your line angle. Let's move to the next one. We have 1, 2, 3, 4, 5, 6, C6H14. So the molecular formula is the same. Okay, we're on to something. All right, cool. Let us now look at the connectivity. When you look at connectivity, the best way to do that is find your longest chain of carbon in the molecule. So let's find our longest chain of carbon in the first molecule. Here's our longest chain of carbon. Once you find your longest chain of carbon, we're gonna number so that the substituent encounter first have the lowest number. So in essence, once you find your molecular formula is the same, go ahead and follow your rules for naming using your IUPAC system to see if that will help you determine if the connectivity is different, right? So the rule when you have substituents is you number from the end that gives the substituent the lowest number. So let us do that. So for here, it's going to be 1, 2, 3, 4, 5. All right. Let's move to the next structure. We already determined that same molecular formula. We're just now using our IUPAC rules to determine our longest chain and name the molecule and follow the rules, sorry, as if we were to name the molecule. So let's find our longest chain of carbon here. Your longest chain is not running straight across. Your longest chain here is, that's your longest chain, right? Now, remember your rule. Once you find the longest chain number from the end, it doesn't matter where we number this time, it would be the same from either one of them. Number from the end that gives the substituent encounter first, your lowest number. So if we look at these two, look at what we're finding out. They both have 5 carbons in their longest chain. So we have 5 carbons connected to each other in a long chain over here. We also have 5 carbons connected to. That's this connectivity and this connectivity is the same. It gets even better. If we look at carbon number three has a methyl group on it. Go over here, guess what? There's a methyl group also on carbon 3 right here. So guess what? The connectivity is not different. The connectivity in A and the connectivity in B is the same. Same molecular formula, same connectivity. These two compounds are not constitutional isomers. They're not constitutional isomers because, like I just showed you, the connectivity is the same. And how do I know that? Because I have 5 carbons in the long chain, so that's 5 carbons connected to each other. 5 carbons connected to each other. On carbon 3, there's a methyl group here. This also has a methyl group on 3. So the connectivity is the same. And like I told you earlier, if you name the molecule, you will also be able to tell if they're constitutional isomers, right? So if we name this one A, if we name A, we get 3-methyl or methyl pentane. And guess what this is? Same thing. 3-methyl pentane. All right. So constitutional isomers again. One, first thing, make sure you have the same molecular formula. That's number one. Number two, just use your IUPAC rules to determine your longest chain and number your substituents as if you are going to name, right? Do that. These two, they have the same name, right? Which tells me that these are not constitutional isomers. What they are the same representation. They're the same representation. Sorry, let me correct that. They're not constitutional isomers. They are a different representation. Different representation of the same molecule. Which is why I tell you, if you're given a question and they ask you, draw as many constitutional isomer as possible, if you name all the structures you play around with and draw, if they have the same name, they're not constitutional isomer. Let's look at one last example, and after this, you should be a pro. So let's look at this example. We're going to do the same approach. So same thing. First thing, let's determine our molecular formula. We have 1, 2, 3, 4, 5, 6, 7. This molecule is C7H16. Over here, let's determine 1, 2, 3, 4, 5, 6, 7. Also C7H16. Remember I said if you don't know where I'm getting the 16 from, please review line angle in our early videos. Once you've done that, let's use our IUPAC rules and one, determine our longest chain of carbon in each one of these molecules. So your longest chain of carbon, also if you don't know how to determine your longest chain of carbon, there's a video titled longest chain of carbon on how to find it. So our longest chain of carbon here is this. Remember, we do this and don't make a triangle. That's my longest chain of carbon, right? Let's find our longest chain of carbon over in this molecule. All right. Let us number these. And remember, we're using IUPAC standards as if we're going to name this, right? That's what we help ourselves in determining constitutional isomers. So 1, 2, 3, 4, 5. So I number from the end. That will give the substituent encounter first, the lowest number. 1, 2, 3, 4, 5. So in this particular one, I couldn't number from here because my substituent encounter first with my red numbers would have been on 3. Just in case you have forgotten that again, you can review that in we already did that in some videos before. So now, following IUPAC rules, okay, I have done my long chain based on those rules. Let's look now. The only thing left now is to say, okay, is the connectivity the same in these two molecules? So let's examine that. All right, cool. I have 5 carbons, right, connected in a long chain. That part is the same, cool. But over here on carbon 2, I have a CH3 group. On carbon 4 here, I have a CH3 group. So I have a methyl group on 2 and a methyl group on 4 in this molecule, okay? Come over here. On carbon 3, I have a methyl group, and on carbon 2, I have a methyl group. So 2 CH3. On carbon 3, I have a CH3 group. So this tells me the connectivity in these two molecules is not the same, right? Because on carbon 2, I have a CH3, right? Cool. Same thing happening over here. All right, cool, no problem. But look at 4. Carbon 4 have a CH3 group. Carbon 4 over here don't have any. Carbon 4 here has a CH3. Carbon 4 here does not have a CH3. The CH3 is on 3, which tells me that the connectivity is not the same. So I have the same molecular formula, but different connectivity. So voila, these are constitutional isomers. So constitutional isomers. First thing, determine molecular formula. They have to be the same. Once you do that, use your IUPAC rules, and now you number, find your long chain clearly, then number based on UN number, so that substituent you encounter first have the lowest number. You see, once you do that, you can see if the connectivity is the same or if the connectivity is different.